Okay, looking at plotting equations and reading plots of equations. What? All right, so reading lines on the quick check came up with some issues. All right, so what is the slope? What we talked about last time is we have the form of y equals mx plus b. And you can see how these things line up, right? Okay, so m is your slope. That is what we are focused on. So I'm going to highlight that part. I'm going to highlight that part. So this question was as simple as 2. I know you can identify that. That's not a problem. Now, every single time that we've dealt with something, I've always asked you, what's a number that we could divide by to where it maintains the same value? And every single time you've answered 1. So that is our slope. This is the rise, and this is the run. So a positive 2, if we're rising or falling, whenever we had our talk, you said that positive 2 would be moving 2 up. So 2 up, and 1, a positive 1 for the run would be going either left or right, and you said a positive 1 would go right. That's not the answer you chose, but anything you missed, I'm going over. So just to reiterate, in question number 3, you solved this like it was an equation instead of an inequality. And I wanted to put this in because I want to keep this streaming through. I want you to keep on thinking about this. When I see an inequality, the statement needs to make sense. All right, so I'm going to rewrite this as an equation and solve it the way you did. So I'm going to go and make a X and Y table. And let's see if we can make some true statements, okay? Negative 2x. All right, so I'm going to take an x value 0. Okay, I'm going to sub it in. So negative 2 times 0 plus 5. Following the order of operations, multiplication will come first. So negative 2 times 0 is 0. Now we have 0 plus 5. That means y equals 5. Okay, now let's take this idea of subbing and do the same exact thing with the inequality. So I'm going to erase this part right here. No, that's not the eraser. I'm going to erase this part right here, and I'm going to put the inequality that we originally had. Okay? Now, if we're saying that y is greater than 5, what would be a number that's greater than 5? Now, if we had this underneath the symbol, greater than or equal to, 5 would work, but we don't, because 5 is not greater than 5. So a number that's greater than 5 is 6. So any number above 6, so any number greater than 6, greater than or equal to 6. It could be 6, because 6 is greater than 5. So this is what I'm talking about whenever you input the x value of 0 and you output the y value. Now if we have this side equaling 5, and then we put a number in for y, 5. 5 is not greater than 5. Not a true statement. So what can y be? Y can be any number larger than 6 or equal to. Okay, we didn't go over this at all. This was simply me just seeing if you could rearrange numbers, all right? So this is what we were looking for. Slope-intercept form. And here is one not in slope-intercept form. Can you use the algebraic concepts of balancing an equation to move stuff around to make it equal y equals mx plus b? All right, well, here's how this looks. So although we cannot solve this problem, I don't know what x and y are, and we're not looking for that. We're looking for just moving the pieces around. So I want y by itself. So I'm going to move 6x minus 6x. And I hope that this shows you that the rules apply as they always do. This is what makes this math so great, is if you're able to do it somewhere else, you can do it on another thing. It doesn't have to be only on that idea. So we're left with 2y equals 12 minus 6x. Okay. If I want to know what y equals, I need to divide everything by 2, because right now I have 2 y's. And if 2 y's is equal to 12 minus 6x, then I know that 1 y would be whatever half of that is. So just like before, I want to get down to a single y. How do I get down to 1y? I divide by the same number. So 2 divided by 2 is 1. There's my 1y. And then divide this whole side by 2. 12 divided by 2 is 6. 6 divided by 2 is 3. This is y equals b minus mx. So again, identifying the pieces. I'm not disappointed at all that this wasn't understood. I'm throwing stuff in there so you can see it. So the thing that's next to x should be on the other side of the equal sign, so negative 3x. And then we had a positive 6. That is the most correct answer. And if you're sitting there going, I think my brain just melted out of my ear. Not a problem. This is another piece that we're just going to keep on introducing, and then eventually we'll have a lesson on it. All right, what are 3 coordinates? This is the same exact thing as what we did earlier with the inequality. So I'm going to take an x value and put it in for x. 0 plus 1, 1 plus 1, 2 plus 1. You can see that I used all 3 x coordinates right there. Now all we have to do is figure out what it equals, and that will be our y. See, look, y. 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is 3. There are 3 ordered pairs right there. So eventually this is going to have to get done. This is going to have to be done with fidelity consistently. Just to review these things, I told you that I would, and I think that it's absolutely important to do so because these symbols mean way more than what we're writing on paper. They are statements, and it's written in a mathematical code, and you need to be able to read this mathematical code to be able to communicate ideas to people. All right, so equal, greater than, that means it has to be bigger than the thing it's being compared to. Less than, it has to be less than the thing it's being compared to. 3 is less than 4, true. 3 is less than 3, false. This is where you can have the same number on both sides. And it tells you that it includes a number, which is represented as our solid dot, or our solid line on a graph. And this is going to be our dotted line on a graph. And this is going to be our open circle on a graph. Okay? All right, so what we did last time, we were talking about using the parts of slope and y-intercept. I went ahead and threw in x and y only to show you another way of approaching a problem like this to verify your answer. All right, so there are 2 components here out of 4 total. So right now, the emphasis, what we did last time, was on the first part. Second part is now. So I'm going to go over what we did last time. So all I asked you to do was identify M and B. We know that M is 2, and I'm always asking you, okay, so what goes underneath every whole number? And you always say 1, rise over run. And then we had our B, which is plus 1. The whole purpose of what we did on the last week was, do you understand rise over run after I modeled it for you? And do you know where to begin your rise over run? It'll always start at your y-intercept, which is B. So I'm going to go plot at positive 1. And then you're going to go up 2 because it's positive, and then right 1 because it's positive. Okay, and I asked you to plot those because I want to, 1, check to see if you're able to plot, and 2, do you understand the trend of the line based on slope? And the reason that I have x and y here is to check these. So I just drew a line using the rules of slope and y-intercept. Let's go ahead and go to 0, so side to side nothing, up 1, 1, 3, 2, 5, and it would be right there, 3, 7. All we have to do is pick any of these and substitute them in, because obviously it's saying a pattern, plus 2, just like our slope, plus 2, just like our slope, plus 2, just like our slope. It's going up, so that's why it's plus 2 instead of minus 2. 2 times 0 is 0 plus 1 is 1. Check. 2 times 1 is 2 plus 1 is 3. Check. Okay. This makes sure that everything you're doing is 100% accurate. So just to review, m is slope, that's the rise. And we'll get into why it's y on top and x on bottom instead of it going x then y. We're doing stuff backwards right now, and there's a very long explanation as to why. And once we become masters of working forward, then we work backward, just like you did with solving equations. And b is your starting point, your y-intercept. I'm going to write down a random equation and just plot it. All right, just from that information, I know that it's going to start at positive 3. And just from the information next to x, I know it's going to go down 1, right 2. So this is, again, we're still reviewing what happened last time, and I think it's good to constantly go over and, in addition to, add new content. So this is a negative slope because when you read it from left to right, it's going downward. That's what makes it a negative slope. All right? I wanted to include more examples of what we did last time because I think it's incredibly important that you understand the M and the B. I'm going to go through these kind of quick, and I'm not going to check the coordinates every time, but I will substitute a 0 and a 1 in, and then use the pattern from the slope. So then the slope is negative 3 over 1, and B is positive 3. So plot it. So we already have 0, 3. Boom. It's right there. And then down 3, 1, 2, 3 over 1. And there's 1. All you need is 2 points to plot a line. So that's 1, 0. Boom. You can see it decreased by 3, just like our slope. So we could go ahead and do this, since these are consecutively increasing by 1. 3, 0, negative 3, negative 6. That generates all of our coordinates. 2. If the line was straight, it would be on it. You did have a very good question. I don't know what to do when there's not a number in front of it, so you can just put a number in front of it. So M and B, 1 over 1 and minus 3. Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. You can plot as many of those points as you want, and forgive the line. You get the idea. So negative 3. There it is. 1 minus 3, negative 2. And you can see that this is increasing by plus 1, just like this positive 1 that's right here. So that would make this negative 1 and 0. Plus 1, plus 1. This has a purpose. We're just not there yet. And then, what about the wonky ones? Honestly, the wonky ones are the ones that make the most sense to me. Down 2, right 3. So we're going to start at positive 4. Down 2, right 3. Down 2, right 3. This was the idea of what I was going for at the instructions at the end of the last video. I wanted to see if you could just do a plus sign, start at 4, plot a point, and say that it's going to kind of go down this way. So what about writing an equation from a line? So not about you're given an equation, Now please make the line from that equation. And yes, seriously, I'm just going to put some eyebrows on him. I feel like he's like just too bald, you know? Let's put like one of those side mustaches, a little like, and then goatee. Let's put some ears so you can hear what we're saying. Okay. Put some dots because he shaved his head, but he has stubble that leads into a beard. Okay. And he's got stubble there because he shaves there because he wants to be intentionally cool. And we forgot a nose. That actually looks kind of creepy. Anyway, we're going to be writing an equation from a line, so we're reversing the process of what we did last time. And we're going to see what that looks like. Hey, oh, there we go. All right. So this is how you do this. All right. I'm going to show you on this one, and then I'm going to encourage you to pause the video on the remaining problems that we're going to cover. So the y-intercept. That's where I'd always start. Where is this line crossing through? On the y-axis. On this axis right here, where's that line crossing through? It's crossing at 0. Whoa, good answer. All right, so I'm going to put a 0 there. That means that automatically we have a plus nothing at the end of our equation. So this is our y equals mx plus or minus b, okay? I can't put minus 0. I guess I could, but there's no point. You don't even have to put the 0. Then the slope. All right, so if we know that this is a point as well, what we can do is start at a point that's given, count how far you have to go up or down. 1, 2, 3, 4, 5. There's your rise. 1, 2, 3. There's your run. Okay, so now we have y equals 5/3 x plus 0. Okay. In a way you can check that, and you might have to simplify some of these. And a way to check it is to do it again. All right, if I go up 5, 1, 2, 3, 4, 5, over 3, 1, 2, 3. Awesome. And I'm also going to be asking you, is it a positive line or a negative line? And we know that when we read from left to right, this line is going up. Up is positive. So there are 4 questions I'm asking you on every single one of these. And that's it. That's all we're doing. This part right here. That's all I'm asking you to do. Okay? That's it. You don't have to draw anything, at least not for these. Go ahead, take a pause. See if you can identify any parts. If you can identify any parts, that's cool. If you want to approximate, that's perfectly fine. If you're sitting there going, I'm not ready yet, cool. Then keep the thing rolling and let's talk it through again. So here's what I know just by looking at this line is the y-intercept is not necessarily clear. It's in between 0 and 1. We could say it's a half. I'm not sure yet. But what I can tell you is the slope. So what we can do is start from a point that's given. And I want you to use judgment. That's why I'm putting these on here, is I'm not really sure where that y-intercept is. Okay, that's fine. So we'll just leave this blank for right now. I do know that we have a negative slope. So I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so down 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, over 9. All right, and the only reason I wrote it over here is because I was going to make sure I had room to write if this could be simplified. So this is our slope. And on these types of problems, since we're not going to go into finding where the y-intercept is, it's not clear. Notice that it's in between. And I'm not going to try and pull teeth on this. I just want you to be able to identify the parts you can identify. All right, so we're going to leave this blank for right now. This is a kind of problem where we're not going to put this. But we did identify the slope. We did identify the m, or the first part of our equation. Now the only other thing I'm asking you to do is it positive or negative? And you read it from left to right. Is it increasing, or is it going down, decreasing? In this case, it would be a negative line. And plus, you can tell from your slope, it has a negative in it. That's what makes it a negative slope, is the negative slope. All right, I would encourage you you should be able to complete every part of this one. So pause, make an attempt. All right, so I'm assuming you paused and you made an attempt. We can start with the slope, we can start with the y-intercept, whatever you want to do. We can start with positive, negative. I can tell you that reading the line from the point on the far left to the point on the far right, the line is increasing. So we have a positive line, and we know that we have a positive slope. So we will not be dealing with any negatives. I'm going to start with the slope. Actually, you know what? I'm pointing at the y-intercept right now. This is where the line crosses through the y-axis, -5. There's the second part of our equation. Done and done. Slope. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So 10 over 1, 2. Okay. So can you simplify 10 over 2? Yeah. It's the same thing as 10 divided by 2, but we want to keep a rise and run. So we know that 2 goes into this. Or I mean 5, I'm sorry. 2. Whoa. Largest number that can go into 10 and 2 is 2. So divide by 2. 5 over 1. Okay. So for the most clear answer of an equation that you would give, and the way you can check this as well is up 5 over 1. Watch this. If you wanted to, I'm just trying to show you all the stuff that's happening here. So we went up 10 and we went over 2. That got us from one point to another. There's a point on this line that's not marked. Up 5 over 1. 1, 2, 3, 4, 5 over 1. There's a point right there. So that just verifies that we are correct yet again when we simplified that answer. The most correct answer you could put here is 5. So y equals 5x minus 5. That's this line that we're looking at. It's a positive because there's not a negative in the slope. This is the most appropriate way to write slope from a student-teacher perspective. This is the most correct way to write an equation. You can definitely do 5 over 1x minus 5. That's perfectly fine. All right. This is going to be one of those where you might go, I'm not sure, and that's perfectly fine. But here's what you can find. Is it positive or negative? And what's the slope? And then you can write that slope in the first half of the equation. Go. Okay, so I'm assuming you paused. So we can identify this line. From the left to the right, it is decreasing. All right, so that makes it negative, which sets us up for a negative slope. So that means we're going to go down 1. So down 1, down 1. Over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right 10. Now this is another one of those examples where it's crossing through the y-axis in the middle. I'm not going to assume that that's negative 1.5. I would need to use math to prove that. And we're not there yet, and that's perfectly fine. So this one is going to go like this. And I have these color-coded on the assignments that I'm sending over with you. So if you're sitting there going, how am I supposed to know which ones? Just, I have examples at the end of this that'll describe the color coding. Pause it, make an attempt. All right, you paused it and you made an attempt. I'm proud of you. High five over the internets. All right, so reading the line from left to right, just like you would in a book, that line is going up. We've got a positive line. I'm going to go ahead and tell you that this is not okay. So that is going to be a question mark. Slope, we are counting from one point to another. I'm assuming we're going to be simplifying the rise over run. Okay, so 1, 2, 3, 4, 5. All right, so up 5. And we're keeping this positive because we identified the positive lines going up. And then over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Over 10. Can you simplify 5 over 10? Absolutely. 5 goes into 5 and 5 goes into 10. So that's 1/2. And what I showed you before and checking that, I'm going to show you again. All right, so if we're going to simplify a slope, we want to make sure that that's checking out. Yeah, I think that spending time with me going over math, you're probably picking up that I'm putting down that checking your answers is pretty important. All right, so if we have 1/2, let's go ahead and check that. Up 1 over 2. There was a point that's not labeled. Up 1 over 2. There's a point that wasn't labeled. Up 1 over 2. There was one. Up 1 over 2. You can see how all those points fall in the line following that same pattern. If the pattern would have been something else, like 1 over 3, these dots would have been here, here, and here. And then you'd know that you're not right. But the fact that every single one of them fell on the line proves that we're good to go. Okay? So at least have that part. Y equals 1/2 x. Plus or minus question mark. And the last one, you should be able to knock this one out of the park. Okay. I prefer to start at the most obvious thing. And to me, the obvious thing is the line positive or negative. And it's sloping downward. So negative. Whenever I start at this point right here and I read this way, you can see that it's going down. The y-intercept is right there, sitting for you. Like, hey, what's up? I'm -2. Okay, and that's the second part of our equation. So whenever we see a negative line, we know we're going to have a negative on our slope. Down 1, down 2. So down 2 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over 10. Similar to the last one. All right, so what goes into 2 and 10? 2 does. It gives you -1 over 5. Now, if you're sitting there going, I know what he's going to do next, that means you are learning. There is a point that was not plotted, and that was our y-intercept. And I went ahead and plotted it from the very beginning. Now check this out. We did all that before we figured out what the slope was. Okay? I'm going to show you how when we simplified the slope from the red point to the other red point, that whenever we simplified that, it did actually include another point on the line. So down 1 over 1, 2, 3, 4, 5. Okay, there it was. Our y-intercept crossing through the y-axis. Down 1, 1, 2, 3, 4, 5. So y equals -1/5 x minus 2. Now, color coding. Yes, color coding. I'm going to use the example of 2x minus 3. Okay? I'm going to plot the line. So this is one where you would include everything that needs to be known. All right, so that would be slope, y-intercept, positive or negative line, and the equation. All right, so you're not going to be given this part, but I just needed to look at so I can. All right. So you're going to be given a line that looks something like this. Okay. You're going to be given 2 spots. And what you're going to write down is what I'm going to be writing down over on the left side. MB, positive or negative equation. Okay, just like we did going through all those examples. So I can automatically see that this is a positive line. So y equals something x. All right, y-intercept is at -3. And from point to point, up 1, 2, 3, 4, 5, 6, over 1, 2, 3. Simplified, 3, so that's 2 over 1. All right, so slope is 2 over 1. Let's check it. I just want to make sure. Up 1, 2 over 1, check. Up 2 over 1, check. Up 2 over 1, check. All right, perfect. This is a problem that does not have a color code on it, okay? This is a problem that works out for everything with what we know so far. So what about an orange one? Write the equation in the form of y equals mx plus b, slope, y-intercept, and whether the line is positive or negative. Okay, so that almost seems like it's including everything. So if it's highlighted in orange, it's got an orange crayon box around it. Write the equation the best you can. Write the slope. If you struggle with the y-intercept, completely fine. And then identify if the line is positive or negative. You're going to hand write those things. So you'll have m, b, positive or negative, and the equation in the form of y equals something x plus or minus b. Okay, y equals mx plus b. Then for the red ones, all you have to do is write the slope and whether the line is positive or negative. That's it. So you're going to have m. That's it. Please make sure all slopes are simplified just like we did in previous problems. The other page you're going to be looking at, this is problem number 1 from the other page. All I'm asking you to do is write that. And if you want to be kind to me and put number 1, that would be cool. And if you even wanted to write the equation down on the sheet of paper, that would be cool as well. You don't have to though. So slope, all you're going to be doing is writing the slope and the y-intercept. Done. Move on to number 2. I hope that this is coming along nicely and is informative for you. Please reach out, text me. We'll set up a Google Meet